Hi, geometry friends. We are in chapter 4 and we are looking at a really fun chapter or section in the chapter. Actually, the whole chapter is fun. We're going to look at classifying triangles, which is not going to be something totally new to most of you because all these words you've seen before. I'm pretty sure of it because I know we've talked about some of them. Definitely, we have. All right, so we talked about acute angles. We remember acute angles are angles that are less than 90 degrees. Well, an acute triangle is a triangle where all three of her angles are less than 90 degrees. So if I were to say this is like angle A and this is angle B and this is angle C, then I would know for a fact that each of these angles is or has to be less than 90 degrees. In order to have an acute triangle, all three angles of your triangle needs to be less than 90 degrees. We also have a triangle called equiangular, and we see the word equi or the prefix equi, which obviously refers to being equal, and angular refers to angle. And if you thought about equiangular as being equal angles, then you got it. So if you have a triangle that is equiangular, it means all three angles are equivalent. And this figure right here represents an equiangular triangle where all three angles are equivalent. Just for kicks and giggles, if we have an equiangular triangle, what would the measure of each of the angles be? Remember, the sum of the interior angles of any triangle has to be 180 degrees. And if this is an equiangular triangle, each of these angles would measure what? I know you're screaming 60, so I'm just going to say excellent job. Each angle would have to be 60 degrees. The next type of triangle we're going to talk about is an obtuse triangle. We remember acute means less than 90 degrees. Obtuse angle means greater than 90 degrees. And so we have a triangle where one of its angles is greater than 90 degrees. So I think this angle here would be the one that's apparently greater than 90 degrees, and that would classify this triangle as an obtuse triangle. And the idea of a right triangle comes from the idea of a right angle, and we know what a right angle looks like. A right angle is an angle that is kind of like every corner of our house, or at least we hope they are. Perfect 90-degree angle. And a right angle triangle is a triangle with one angle that is a right angle, 90 degrees. Equilateral triangle. Now we're getting into the sides. These three triangles are going to be described by their side. So an equilateral triangle refers to a triangle who has equilateral sides, equal sides. Three equivalent sides would give you an equilateral triangle. And so if I were to draw that, it would look something like this. And we would use hatch marks to emphasize the equality of the sides. And then we have an isosceles triangle. Isosceles triangles are triangles that at least have one or a pair of sides that are equivalent. So these two being equal lets me know that I have an isosceles triangle. And finally, we have a triangle that we refer to as scalene. A scalene triangle is a triangle where each of the three sides are different lengths. Scalene. So this might be one length, this would be another, and this is a whole other length. And I think that you have heard of these before. I think you have. And if you haven't, do memorize them because we will be referring to them frequently throughout the chapter. To go along with our discussion in your text, you will find a very similar key where they give you just a brief look at how you can identify acute, equiangular, obtuse, and right triangles. Just a note, equiangular triangles also happen to be equilateral triangles. And this is the only shape where that always happens, and we'll discuss that at a later time, but that is the case. All right, let's go into a couple of examples. So just like the section states, what we're going to be doing is classifying triangles by angles. So as we look at these angles here, we're going to classify whether the triangle is acute, equiangular, obtuse, or right. And so clearly we can see it's not equiangular, this first one, part A, because all the angles are not equivalent. Obtuse would mean that one of the angles would have to be greater than 90, and that's not the case. Right means that one angle has to be 90. In this case, it's not the case. So finally, the one that I skipped, acute, all of the angles, each angle is less than 90 degrees, lets me know that I have an acute triangle. Moving on to part B, we're looking at these angles, and this one shouts at me 90 degrees. So this is a right angle triangle. Because I've got that right angle, I've got a right angle triangle. And that's it for identifying triangles or classifying triangles by their angles. Let's take a look at example 2. We're going to look at their angles and we're going to see if we can find some more information about this particular one. So I guess that wasn't it. Here's more. Classifying triangle PQR, identifying PQR as the larger outer triangle. So classify this triangle as acute, equiangular, obtuse, or right, and explain your reasoning. So as I look at the larger triangle, sometimes it's actually helpful to highlight it, and so I'll highlight it here in red just to keep my eyes focused on what I'm looking at this guy. And I look at each of the angles, and if at a quick glance it looks like all of the angles are less than 90 degrees, but P is one angle, R is another angle, and Q is a whole other angle. And so breaking it down here was a little slightly, looks a little tricky, but it's, you know, if we pay attention, we see that 45 plus 59 is definitely greater than 90 degrees. Adding these two angles together, we get that the angle Q is actually 104 degrees. Angle PQR, if I'll be specific, is 104 degrees. And so we clearly recognize that we have an obtuse triangle here in triangle PQR. Going back to talking about triangles or describing triangles from their sides, we've got triangles that are equilateral, all three sides are congruent, isosceles, two sides are congruent, or no sides being congruent. That's our scalene. Let's try some examples. I love calling this a real world example because it's a real world example, right? So classify the sound box of the Russian lute below as equilateral, isosceles, or scalene. So if you look, you can see that two sides have the same measure of 16 inches. So the triangle has two congruent sides, and therefore it's isosceles. I don't think it was that hard, and I did leave the answer here. My bad, people. But the answer is isosceles because both of these are equivalent. Let me do better next time. Let's look at another example. Example 4, we're going to classify triangles by sides within a figure. So if point M, I like to write right on it, so if point M is the midpoint of JL, so we see this hatch mark here, and I put this here, anticipating it. So point M is the midpoint of JL, classify the triangle JKM, and again, I like to highlight when I am asked about a specific part of a picture and not the whole thing. So I'm going to classify this picture here in red as equilateral, isosceles, or scalene, and we're going to explain our reasoning. So they gave us some numerical values here which just serve to confuse me. So what I'm noticing is that if this is equal to this and this is equal to this, then this is equal to this. You guys with me? So if we have, let me go ahead and mark this in black, if these two guys are equivalent, then we have, drum roll please, oh no, oh look how dope this is. I was going to say we have an isosceles, right, because two sides are equivalent, but we got something even more special than that. How do I know? Well, JL, and you guys probably thought of it before because you're smart, and I'm just trying to catch up. JL is length 1.5. And if it's length 1.5, half of JL, because M is the midpoint, is going to be 0.75. Yeah, I hear it. I hear it. You guys are like, ooh, this is awesome. Math is happening. So that's 0.75. If that's 0.75 and this is the same as that, then this is 0.75. You see where this is going. And this is, and then, oh my goodness, we have not just an isosceles, but we have even more important an equilateral triangle. Bum, bum, bum. So equilateral is the answer here. That last one was pretty fun. Let's check out example 5. I don't know if the fun can continue to be as amazing, but we'll see. Find the measure of the sides of this isosceles triangle. So we are asked to find these lengths. We're given an equation here. Well, we're given not an equation, an expression with x. Each side is represented with an expression of x, and we are given that AC is equivalent to BC by these hatch marks. And so I have that. I'm going to use that to my advantage. Therefore, since I know AC is congruent to CB, I'm just going to set the measures of each of those lengths equal to each other, right? Each of those sides equal to one another. And so when I do this, I get a handy dandy mathematical algebraic equation, and I'm so good at these now because this geometry book is chock full of algebra, right? Which is awesome. I can solve this pretty easily. Move this guy over to the other side, and I get 1.5 is equal to x. And you know how we were like, hey, I'm finished? No, you didn't, because we were asked to find the measure of the side. So we've actually got to plug this business in here and solve for each of the sides. So I've taken the liberty to substituting 1.5 in for x, and 4 times 1.5 is going to be like 4 times 1, which is 4, plus half of 4, which is 2, and then it's 6. So I end up with 6 plus 1, which is 7. 5 times 1.5 is like 7.5, 7.5, minus zero point 0.5, which is 7. Woo, because if they didn't come out equal, bad things would have happened. We would have been confused. Over here, we get 9 times 1.5, which is, I think I'm doing this right, 13.5. Like first 9 and then plus half of 9, which is 4.5, and 9 plus, yeah. Minus 1 is going to give me 12.5, and that feels okay by me. All right, that felt good. And I think that was enough for you guys to be able to go ahead and get started working on the first assignment in chapter 4. Take care.